Um, I guess I'll just kind of start going through the stuff. If you have questions, just speak up because it's hard for me to kind of keep monitor with the chat and everything. So, screen 2. So I'm kind of going to go over some just core terminology type stuff in the beginning. I wasn't sure quite how to gear experience levels for this, so I apologize if it's too beginner level, but I'll try to get through the terminology kind of quickly, and then we can get on to the demo part of it. So my name is Jason Madden. I own a consulting company in Fort Worth. So I'm geared towards helping companies with .NET development for full stack applications. I do a lot of database development and kind of just really doing the implementation of just fancy input forms and managing data processes between different departments and things like that. So I finished my master's about 10 years ago, and that was focused on cybersecurity. And sadly, I haven't really got to use it that much, but I still enjoy what I do, but I wish it would have been more along those lines. So Postgres has been around a while. Kind of all of the RDBMSs have all been kind of late 1980s because the need kind of hit at the same time. A guy by the name Michael Stonebreaker kind of pioneered it, come up with the idea. I didn't really actually know him that well until I kind of studied for doing the webinar, but he was in education, kind of left to build a database infrastructure as a company, and then ended up coming back and kept iterating on it. And one of the innovative things that was added to database management that he included was data type. So I mean, I've never known a database not knowing what a data type was. So I'm sure at the time it would have been just the time killer on having to manage all of that. So he is a very entrepreneurial type guy and still in education. So he has a lot of startups and is kind of his whole career is geared around databases and data management. So pretty cool guy. And he's kind of ancient in terms of when you see a developer, I kind of thought, but still in there. So so what is Postgres? And I'm just going to kind of bundle this in with, there's MySQL and Microsoft SQL. These are all very similar. So it's a relational database. All of your data structure is well defined. You set all the data types. You have to meet all of your constraints, all your conditions to insert data and be able to track it. You have little flexibility if you don't support the types that you're trying to store. So depending on what you're doing, it can be good or bad. Operating system wise, Postgres is hostable on all these operating systems. So FreeBSD, I know, is still pretty common, especially in the Docker world. HPX, I've actually worked with it, but it's pretty well dead. Linux is very popular because of all the Dockerized and the containerization. BSD, OpenBSD, these are all the flavors of BSD, kind of forked from Unix a long time ago, and it's its own thing. Mac, Solaris, you still hear about. Unix and Windows, everyone is familiar with those. So very flexible on where you want to host, especially if you're doing containerization. I wouldn't recommend doing containers for hosted servers, but for development, keeping your environment clean and being able to experiment, it's a great kind of platform. So access methods. This is talking about what type of code frameworks can you access the database in. So ADO.NET, that's specific to .NET, and C#. It's just kind of, you can load the DLL. It preloads a lot of the management of your connections and mapping of your objects and things like that. If you're familiar with the term ORM, Object Relational Model, that's kind of what this section is talking about. JDBC, that's a Java, and it allows you to connect your Java application to a data model. Kind of similar to what ADO.NET does. It wraps all of the connection logic, things like that, and helps you build queries to pull into your applications. Native C, so if you're familiar with the C language, it's type safe, but not really memory reference safe, so it's very easy to get in danger. You'll still see a lot of AI applications and driver libraries being built in native C, just because it's like a step above compiler code. You don't have all the bloat of the language trying to manage your memory and things like that. ODBC, this is kind of the connection framework that Windows uses by default. So if you need to set up a connection, you can use this layer, and many frameworks will fall to the ODBC kind of standard. So if you're connecting to it, any sort of weakness that you may have is going to be through that. It's just kind of a connector standard. Microsoft SQL also uses this. MySQL does, and Postgres, all three kind of do it. So programming languages, these are all the supported ones. The most popular are Java, Python, and C. So I will say, when you run into different languages, kind of as you go through your career, you may have to switch, or you just get opportunities you like and have to learn a new language. A lot of times the language is kind of married up to a specific database. So my background is mostly in .NET, C#. So I do probably 60% C#, Microsoft SQL, 20 to 30% MySQL, and then the rest is kind of filled in with Postgres. So more of the front-end applications, the more modern, kind of like the Angular Node.js applications, are Postgres. So let's see. So pros and cons of RDMS. So if you have heard of MongoDB, I'm assuming you probably have. It is an unstructured, or not that less structured database. So basically it takes JSON objects and builds a data model around that. So you have a lot of flexibility with being able to track just arbitrary data. You don't have to conform to any sort of standard to fit it into your databases. There are performance improvements with NoSQL, faster writes and reads, because it doesn't have to validate and try to conform to standard, your schemas and things like that. You get performance benefits. But the beauty is unstructured data. So in the big data world, as people interact with applications, you don't really know how to track a model. You just want something quickly to load to the UI. NoSQL is a great solution, just because it's very quick to develop and the speed. But you come into issues because of versioning. So let's say you set up a class, it tracks certain things. You update it, you kind of have to manage how you update it in the long term. So you have to be able to support different versions of data. And a lot of this is already handled in your NoSQL solutions, but you do have to think about it and be more cognizant of it. So, but what we're talking about today is the relational DBMS, so very highly structured. You run into scaling issues when your data set becomes very large. So like in the world of Azure and AWS, how do you manage region-specific data and be able to tie that all together? Tables can get very large, and there's a way to optimize and partition them. So you can build partitions based on year and try to incorporate ways that when you do queries, you're not querying the whole world. So it becomes issues with performance as your data set grows and as it spreads across your globally and things like that. So I will say that most of my work has been for enterprises, and the solutions are more hosted in-house or relatively small user base, so anywhere between 200 and 1,000 users. So I don't run into scaling issues as much, but this is something to be aware of. So rigid structure kind of goes back to the converse of flexible structure. You have it's almost like the Excel sheet view. You have to cram data that fits in the parameters of what the definition is. So here's an example, just kind of going through structured versus unstructured data. Let me check the time. Okay, 3. So unstructured, very arbitrary. You don't have, typically you would see JSON objects, but this image I just cut illustrated all of them well together. So you've got a lot of data that you would eventually have to extract out to make meaning out of, but you don't have to do that up front. You're able to capture it and then you have it until later. So you know how to read it, but you can't ensure what the content is because it's there. So semi-structured, this is like your XML, JSON objects even. So if you don't have some sort of schema or something that you are conforming to, but you still have the restrictions of how your transactions happening, so you still have to conform to some standard. So relational database management systems, they do not handle that unless they have a schema, or you can just throw it into NoSQL. So structured data is the one on the right. So you have columns, you have rows, and you have tables. So you have to fit your model into that. Most of the time for enterprise solutions, you have to think about how you want to track it and develop your whole data model around that. So a lot more thought in the beginning and kind of lifetime of the whole application. So I thought it would be good just to throw out a comparison for other relational databases. You'll see that once you learn one really well and kind of understand all the different important features on it, it's really easy to jump across to other ones. Being a full stack developer, of course, you need to be aware of some of the underlying things, but for the most part, you're shielded with it. You're just focused on building application. And most of the time, you'll have people on your team that are dedicated to make the real fine-grained optimizations and things like that. So comparing kind of the top 3, these are almost the most popular, and also ranking-wise on this comparison, they're very close. So they all, some of the differences is kind of what I brought up before with language specific. Some like Microsoft SQL is a lot better aligned with C# and Windows development. MySQL has recently went more license based, and there is the fork MariaDB. So both of those kind of would fall under this category. Read speed is very comparable. I think when I looked at it, the Microsoft SQL may have been a little bit faster in things where it was a close second with MySQL and Postgres. But you pick one, you can't really go wrong because they're all popular. I know MySQL and Postgres, they're a lot easier to get hosted on AWS and the Google Cloud. Azure, Microsoft SQL is there. But so the I wouldn't, not a whole lot to say here other than they're very similar. Oh, I will say Microsoft SQL, you're going to have a license. Postgres is free, very well supported, nice community. So it's a good solution for the startup where you're trying to keep costs low and still having a good solution. So now kind of on what I'm going to demo building in the PG admin. So we're just going to build as a very simple entity model, include 3 tables. So all your tables have to go into schema. Schema is almost just like a namespace. So anytime you build your query, you'll have to do the schema name dot and then your table name. And you can set permissions based on schema. So if you're working on a bigger company and they silo off the teams, get the data models off from seeing each other, this is a way that you can enforce roles and optimizations on your schema and things like that. So, and also it helps with the API security. So if you're exposing a data set to the world, you do have to, provide something, but you want to minimize your risk. So it's kind of the uses of the schema. And also, and going back in a namespace. So let's say you have 2 user tables that need to exist on your full data model. One way that you don't have to do any funky naming is to wrap a schema around that user table. So you could have like customer users and then a vendor user, something to that nature. So the next component that is crucial is the table. So basically a table is a collection of fields and it represents some sort of entity you want to represent. So a couple things to kind of be mindful of as you build tables. Look at your row size. There are limitations on what is optimal for a row. I forgot to look up that number, at least for this talk, but the culprit will always be your varchars or variable character strings. If you have 2 or 3 on your table that are max size, that can explode bad, and then it starts to get hard to optimize your read and inserts and things like that. But so to columns represent some sort of just a data type, and that data type will be stored, and you can name a column. So really special ones are your ID fields. So in proper database design, you'll always have either a GUID, globally unique identifier, or an integer that's auto incrementing. Those will be your primary key for the table, even though it's a little bit of extra work if you need to set up some sort of other unique identifier. Typical design, you'll always have the GUID or integer. And just make sure terminology is straight. It's interchanged with attribute. I'll try and stick with just column, but if I mix it up, that's why. So columns also give you specific rules that you can set for variable types. You can do constraints. I won't really go into constraints a whole lot, but that is another sort of restriction you can put on your data that may not conform to a data type, and it may be more business logic specific. So social security number, for example, does not have a field in a database to track unless you as a business to define that object inside your data model. So you would use something like a string, but you have to enforce that people could put dashes in it. They could leave it all alphanumeric characters, things like that. So you can add constraints onto columns that help you enforce your data cleanliness and just consistency. So another important component is indexes. So indexes are the way a database manages looking up data. So B-tree is a very common way to do it. I won't go into the details too much just because it's a little bit down in the weeds. But and then another very common one with Postgres is hashes. So basically, these give the database shortcuts on queries and lookups to be able to find your data quickly. So it's an expensive operation if you're just you're searching for a specific word in some field. So how do you go about looking at that? From conceptual model, you have to crawl through your columns, and then each column you have to crawl through the text. So it's a polynomial based type of lookup, where if you're looking up specific like user IDs, just primary keys, things like that, you want to be able to quickly be able to jump to that item, have some sort of way that the database structures and looks it up to get to it, and then pull the rest of the contents of the row back. So by default, Postgres will create indexes on the primary key. And anything extra than that, you have to be able to define. So now this is one weak point of relying on ORMs and kind of doing everything code first. The new way of doing things is to have your ORM. So for Python, it's SQL Alchemy. For .NET, that is Entity Framework, or in Hibernate. Those, you can define the objects in your code. It will kind of create in memory the SQL representation of it, and then generate scripts to make your database look like your classes that you've set up. So it's very convenient and makes it very clean code management because you're only looking at one place. But when you run into performance issues, you really have to, there's no way not to have to dig into SQL or more on the execution side of the SQL to find ways to optimize it. So indexes is one thing that you can't get by with not being more married to your database model. So unique indexes. So I'll bring this up because you have things like social security number. Even pretend that's unique for now. So for a person row, you would have a primary key, which is the user ID, but another unique ID could be their social security number. So you would never want to return back the social security number in a call. But if it's requested on the database, you know it's unique and you want it to be able to find that person based on it. So a unique index is what lets you define that, and then also gives the database the shortcut to be able to look it up. And then multi-column indexes. So oftentimes when you look at making sure your database is, I think the proper term is normalized, but it's basically you want to make sure you don't have empty columns. So you may have to break up one entity into multiple tables. So in the example, we'll talk about a simple customer model. Actually, I can bring up the slide. So we have a customer. A customer can have one or more addresses. So that's kind of part of the diagram. So if you look at the connectors, I try to conform to this, but in industry, I saw diagrams all over the place. It's really more common to be something on the whiteboard and you end up just taking a picture and throwing it in Jira or something. So a customer can have one or more addresses, and then this address table is actually inherited into the customer address. So as we go through the example, I kind of point these things out a little bit more, and kind of how it's implemented. But the multi-column index kind of comes in with this customer address table. So the primary key is the customer address. Another key that you could use for this is the customer ID combined with the address ID. So Postgres by default does not define foreign key relationship. So a foreign key relationship is going to be from the customer address table back to the customer table. The customer ID is a foreign key, and that's the denotion of FK. So Microsoft SQL is different in that fact that it actually does an index on that foreign keys. So Postgres is a lot more lean. You have a lot more work to do up front, but it keeps that performance, tip top as much as you can. So I did put an example on GitHub, kind of what I'm going to walk through. I still need to update it, but the Docker Compose works, and this is an actual database export, so you can go in once you launch your Docker containers. You can go in through the admin side and import this database, and it'll contain all of the example we're going to walk through. So I'm not sure. I can't remember what this link up front. Oh, this link up top has the Docker file I actually used, and then it also does the step-by-step on how to launch it. So I'll eventually get that into the GitHub repository by the weekend. I just kind of got behind on time yesterday. And then a couple things to note that we won't talk about today. Stored procedures. A lot of times when you do code first approaches, it's a little bit messier to do stored procedures. But basically, these give you compiled SQL that are tracked by your database as an object. And it gives you compiled optimizations, and then it lets you execute them via command versus having to send some sort of dynamic query. So ORMs, for the most part, generate SQL, executed against your database, and then it kind of manages the mapping from your results into objects. So stored procedures is a good way to get performance enhancement. So functions give you a way to return values based on your data. It's a lot like a function in your kind of high-level language, but you can do it in SQL if it's something repeated, and you do get the advantage of having compiled SQL and having structured returns back for your data. And then the last crucial piece is views. So if you are building reports or things that are going to get hit a lot and you're tying together more than one table, views are a way that give you indexing and quick access for data without having to tie it all together with your queries. This will load it into memory and kind of keep things real fresh for you to use. And then it just saves a lot of performance hits based on joins. So let's see. So any questions so far? I'll get into the demo now. So see, I'm kind of, okay, we're good on time. So I personally use VS Code for a lot of development and then jump into Visual Studio. So you can integrate VS Code with Docker and you'll get a little Docker management thing. So if you check out the solution and you go to the Docker Compose and do right click and compose up, it'll take this and create an instance, 2 containers. One has this admin screen that you'll see, and you'll have to go in and connect to the database, but the next part, it'll create another container for your Postgres database. So one thing to note on here that I will update on the GitHub is right now, all of your memory is trapped on the container. So when you do anything on your database, if you create a change on this setting and it has to rebuild your image, you're probably going to lose all your data. So right now, the connection ports are here, wrapped here, and then the PG admin goes to 80. So you'll have to put these ports in your browser when you go into it. So let's see, one other thing to show. I hope I... Docker. So these are my running processes right now. I have two that are kind of running along with this, so the example is kind of bad, but these two are related to Postgres and the PG admin. When you do things with your container, you will need this ID. So to find these, you can execute a Docker PS and grab these IDs. And mostly you need this so that you can get the IP of your container later. So yeah, so let's see what else. I'm trying to think. So I think I'll go through and walk through the creation of that little ERD diagram. And then if you have questions at the end about Docker or anything else, we can kind of come back to it. So open game. So anyway, ignore this one. This is the one I kind of created yesterday to be able to walk through and export it. So from the beginning, you'll only see this Postgres table. This is your master table, and it has a lot of lookup things that the server needs to kind of optimize. You can put global functions here that can get shared in some of the other objects. So always your first step is going to be to create a database. So we'll just say customer address. And there's so many different naming conventions out there. So just experience-wise, when I meet SQL admins, they tend to be a little bit more old school about doing things. So a lot of the naming conventions that you'll learn in the code camps and startups, when you get hired onto companies, there's kind of like 3 different very common naming schemes that you'll run into. So I'm trying to pick the modern one, but just due to habit and lack of memory, I may have some conflicting messages. So I'll try to do my best. But so first the database, now kind of back to the schema part. So we need to create a schema, and we're going to call it customers. And all of our customer-specific data, we're going to wrap under that schema. So that'll include, if you think about the ERD diagram, customer address and then customer address. So I'm not going to change any of the privileges or anything. We'll just kind of keep it pretty basic, so you can see how quick it is to get up and going. So, all right, great. So now we have all these sections. So a lot of what you will run into is procedures. That's kind of where you would see stored procedures and compiled code. Your functions, you'll see here, foreign tables. I think when we go into the example, we'll see some stuff come up here. Let me make sure. Okay, so that's going to be foreign tables outside of the schema. And then tables is empty. So our first step is going to be to create the customer table. So, and this may not be exactly the same as the other one because I'm trying to go from memory. So we'll name customer. So this is going to be a little bit of redundancy in the naming convention, but we'll just kind of run with it. So customer table. At a minimum, we want to add the customer ID, which will represent the primary key for the table. In Postgres, there's a data type that's called serial that is basically an integer that is auto incremented, not null, and shortcuts you to be able to not have to manage that when you do insert. So all these settings, I'm going to say it's not null because it's a primary key, which it probably would carry that anyway in primary key. So keep things simple. We're just going to say first name and last name is all we care about for a customer. So variable character. So this is going to depend on what you want to set up. I'm just going to say 125. And just remember that these, I've actually forgotten. Normally they are the 16-bit characters. And then if you do regular characters, there's probably a difference there too. I've forgotten. So typically I just use varchar. That's like you get the full character set, and especially when things are coming from the web, you don't have as much risk coming in with data issues. So and now the last name. Okay, so pretty simple. We're just going to save it. Okay, you'll see that this gets added. We'll have an index. Default primary key is there, so no indexes on here yet. If you want to go back and make changes, you can right-click and go to Properties, and then edit it this way. This will manage kind of generating the SQL, but if you do need to execute SQL commands, you can always launch a your own SQL query window and manually do some of those things, because sometimes you'll run into issues where error messages don't make sense, and you just need to grab the query and run it and then be able to debug down into it. So second table, we are going to get to customer address. So I jumped ahead. So this one's going to be address because we're inheriting. So address table, one of the cool things with Postgres is actually that it supports table inheritance. So Microsoft SQL, you actually have to design your tables around this, and it doesn't really understand the concept of inheritance. But in Postgres, you can actually tell it to watch a base table, and if you start deviating from that base table, it will kind of stop you from making updates until you fix the issue. So it really is good for data safety, and then being able to generalize your entities and to things into different connecting tables. So I'll kind of keep going through this. So address table, we're going to make address line 1. Want to support all the characters we can, 250. And there's probably a standard for this. I didn't bother to look it up, but it's always good to, if you're going to pull a data set, especially if you're going to do like US Postal Service, you can help enforce their rules with enforcing in your data model. So again, it kind of gives you the lowest level of data security. And when you violate it here, there's no way the application is going to keep going. So don't be lazy about the error handling and user constraints here. Even though it throws more exceptions that you have to answer for in the code, it's just very good practice and good defensive coding. So address line 1, I'll keep address line 2. 250. So this is one, I'm just going to use a character array of 2. We're going to say that this rule will never change. Now, when you start doing global stuff, we know it'll kind of conflict with this, but simplicity's sake, we'll go with this. So city. Zip. All right, so I'll stick there. Oh, and then I forgot the primary key. So primary key address. Another serial. Not null. So to add enforcement, we're going to say this should not be null. This should not be null. City should not be null, and zip should not be null. So we'll save that. So now we've got 2 tables. And the one that's going to tie these both together is the customer address. So here you can add the inheritance. So if you want, we're going to pull from that table, and then it will silently kind of include this in a part of the model. So we'll look at how it looks whenever it's created. So all we have to do as far as work goes here is add the customer address. Now, this one is another sort of pattern and practice type thing. Some companies will want to have an ID on every table, and these many-to-many relationship type tables, which this is that example, they don't want to have an ID because you only really care about the relationship that you're tying together. So in this case, it's going to be the customer and the address. So this, again, will be the serial type. And then this will be a customer ID. So remember when we created the customer table that we set the type to serial? In this case, it's going to be referenced as an integer. So because we do not want this field to represent its own thing in this table, we have to define it that way. So next step is going to be, we'll save it, make sure we're at. Okay, so now go back to properties. So next step is going to be to set the foreign keys. Why is that not showing up? Okay, all right. Okay, so constraint. So foreign key. So foreign key, again, we're wanting to relate 2 tables together. So in this case, it's going to be the customer and the customer address. So basically, by adding the foreign key here, we're telling that the customer address should never exist without a customer that it's linked to. So you can set different operations for deletes and updates. So that's called cascading operations, and you'll see the options as we get set up to that. So naming convention wise, FK underscore, and then you'll do the from table customer address to the what entity you're connecting to. Once you kind of set that preliminary stuff, you have to go and select the column. So customer ID, the foreign table will be the customer, and then the referencing column will be the customer ID. So Another naming convention thing that you'll see sometimes is instead of using the verbose name of the table plus ID, so in this case, for the customer table, the customer ID, you may see where it's just ID. So the downside to that is when you are joining two tables together, you can't distinguish what ID is coming from where. And when you build queries, you'll kind of understand what I mean. So verbosity is good in this case. So the action part is kind of what I was talking about with the cascading. So no action is just going to mean it doesn't propagate. But if you want to cascade your updates or deletes and things like that, if you delete from the customer, it will go through and actually delete the rows in the customer address table. Because if it didn't, you would have dangling pointers to the customer table. So just bad practice. But for the sake here, we'll just leave it no action. So, and actually, because it's a foreign key constraint, if you try to delete something from the customer table, it'll complain. So, what else? Column. Not sure what's going on. Okay, yeah. So the last type I was forgetting here was you have to add which field of the current table. So in this case, customer address, its customer ID field is the one that's being associated with that one. So we'll save it. So now you've got a constraint that's going to be between the customer and customer address table. The database will help you manage it, and then it will also, because of this constraint, help you optimize lookups based on this. So we don't have any indexes yet. So let's see. All right. So next thing we're going to add is going to be to the customer table. So let's say we do want to have where the first name and the last name are unique. We live in a small town, so no one has the same name. So how would you do that? So you can right click, go to create, and add an index. We're going to say UX for unique index customer, and then we'll just say it's the name. You don't really have to select anything else, at least from this screen. So I've left everything is the B tree. You'll have to do a little bit of reading just because we can't cover everything on the different ways. The most common two are heap and B tree. Hashes are for your primary key, and then these other ones are more specific to the data type. So for now, I'm just going to say there. And then we're going to say unique because it's going to be a unique index based on the first and last name. So we'll have to add the columns. So first name, just leave everything default. Last name. Okay, so now if you wanted to, let's say you were going to do social security number, you could also do this unique constraint on that, add one column, and then in order to speed up the lookup, you can include more of the fields later. So when it has all this data mapped together, it is just saving you compute time. So that's kind of the benefit of the include columns. But we'll keep it just kind of plain because this includes everything. Save it. So now it'll appear here on this index. if you want to modify it, you go right click, go to properties, and then see all the settings. And then this SQL tab will be what SQL generates the update. So if you actually need to go in and dig and look at the what the query looks like, or maybe where it's running into issues, this will help you isolate it. So I guess for now, that is about all the time I can cover with leaving a little bit of Q&A. So stop sharing. So, all right, any questions?
Yeah, I have a question. Thank you for the presentation.
Yeah.
For indexes, that's usually done to have a faster lookup time on a database, right?
Correct. And yeah. And then you can do it. It kind of accomplishes two things. You can do constraint-based indexes. So, like, if you wanted to do unique name, you could set up a constraint that's unique, but also by setting the unique index, it kind of helps you do some data validation type stuff. So,
okay, and on a database, usually unique, a ID is usually unique, like a customer ID. So would you put another index to have a faster lookup time if you have larger data?
Not so. If it's primary key, you're already taken care of there. So it's always going to try and optimize, but based on the primary key, especially because your joins are often done on keys. So if you are doing if you have alternate keys, kind of like in our case with the, you could say the customer address and the address ID, that could be another unique key that you could define. And maybe you want to define that. So that would be another unique index you could do. So.
Thank you.
Mm-hmm.
I have a question. Would there ever be a situation where you would be able to justify having a table with no primary key? Like if you were joining different, I guess, data sets together into a mini, I think you call them join tables or something. Would that be a situation where you wouldn't necessarily need one, or do you always have to have a primary key by convention?
You don't always have to, but you almost have to have something that makes that row unique.
Okay.
Just for the sake of if you need to find it, how would you distinguish it from something else? So I think you probably could cram a bunch of data in there without primary stuff, and the query engine would have to go through, but it would have no shortcuts to do it. So one thing I meant to look up that I didn't. So a lot of the RDMSs, DBMSs, they're adding JSON columns or ways to manage JSON columns. So one of the new features of Microsoft SQL is you can track a column by varchar, but the SQL engine has ways that you can convert that to some sort of JSON query. So it does Mongo-like queries and things like that. So that may be a scenario that if you are tracking a JSON object in a relational database, it's not the best way to do it, but there's always, extreme cases you may have to do it. So, I went off on a tangent there. I don't know where I was going with that. I'm excited about that feature because, if you're trying to save someone's favorites list on an application, it is a pain to make a structured data set just for one row of favorites, and then you have to worry about a self-pointing reference to the table. So you could have a favorite that is a folder and you point back to itself. So you start having to traverse n number of times on one table, and it gets messy. There's queries built for it, and there's standards, but it's just hard. So anyway.
So I didn't realize that you could run pgadmin from Docker, without actually installing Postgres on your computer. So
Yeah.
with the YAML file, or
Yeah. So if actually, I'll post it. Where's my presentation? So these two links, I made the YAML file, but it's just exactly pretty much what that link has, and it will walk you through how to launch it. And recently, because I do a lot of Windows development on Mac, so I hate running like any resource hungry things. I like being able to just run things through Docker and then shut it down when I'm kind of done with it. So, so Microsoft SQL in the same way will let you run a Docker image. You can run the whole thing. The Microsoft one's very messy about your registry key and things like that, and it adds a lot of bloat. And then MySQL has the same thing. I did not pull images, but kind of like I said before, once you get really familiar with one SQL, it's easy to move across. Maybe not as like a DB admin, but from full stack developer, most of the terminology and patterns will kind of roll over. You just kind of have to watch for the nitpicky stuff. But I mean, that's just like, a couple months you're up to speed. So anyway, what else you got for me? If nothing else, you want to work through the example, let me know if you'll actually hub, and I will work on it to kind of get more of a documentation so you don't have to read through it as much. But if you have questions, you can hit me on LinkedIn, or I don't know if I posted my Skype, but I'll do Skype too if you want to do it. So feel free to bounce questions, or if you want me to look at a resume or something, that's fine. So networking is great. That's kind of one thing I've learned. Like, developer personality is behind a computer. You don't go out much, but you never know when you'll kind of like meet the next person that you kind of bond with. My best development team, we played board games like every weekend, and it was really cool experience. It only happened once, and it didn't it was about a 6-month thing because the company kind of collapsed. But what I would give back to have that again. So yeah. But anyway, so I guess our time's up, and if you don't have questions, I'll let you guys run.
thank you for that.
Yep, you're welcome.
Yeah, thank you very much.
Yeah, thank you.
You're welcome.
Yeah.
Bye, guys.
Bye.
Oh, I guess
we're gonna
go to a new one. Yeah,
Okay,
and then-
that's good. You were like, all
Yeah.
right, I'll see you there. Okay, bye.